Assalamu alaikum. Welcome to lecture number 12 of digital signal processing. In this lecture, we will going to cover the remaining concepts of discrete time convolution, and then we will move towards discrete time correlation. Resuming our discussion for discrete time convolution where we left in the last lecture. So in the last lecture we have concluded the point that we have to time shift the impulse response, or basically we have to time shift the folded version of our impulse response. That is, this is the folded version of our impulse response, this is the folded signal, and we have to shift this signal to the right and we have to shift this signal to the left. So we have discussed till the right hand side shifting, and this is basically the time delayed version of this folded impulse response. Now we have to find the time advanced version of this signal, which is the original signal is shifted to the left hand side. So by this term I mean to say that you have this h of minus k and you have to shift this signal by 1 unit. So as you can see, here is a shift by 1 unit, and minus sign is indicating that it is on the right hand side or left hand side. So you basically shift this signal. 231 is going to shift to the left by 1 unit, and similarly by 2 unit, and similarly by 3 unit. And if we are going to shift it further, then we will notice that this signal becomes 2 here, 3 here, and the sample 1 becomes here. And sample 1, if sample 1 is here, then it will not have any more overlapping effect with the original signal, which is x of k. So we will not shift this signal anymore beyond the 3 units because no overlapping exists beyond the 3 units. However, if our original signal, which is x of k, is present for these samples also, then we have to shift our this impulse response also. So basically we are shifting our folded version of impulse response to the right hand side and left hand side as long as the overlapping exists between the folded version of impulse response and the original signal, which is x of k. So after doing this overlapping or shifting, and basically we are trying to find the output, which is the essence of this discrete time convolution, that we can find the output if input is known to us and the impulse response of the system is known to us. Now we are going to find out the output samples or output values with these sample values of our original signal, which is the input signal, and folded and shifted version of impulse response. So how we can exactly find out the output values or output samples? We will look at the overlapping samples. By overlapping samples, I mean to say at each and every time instant, which is the original signal, and the time instant I am talking about the delayed or shifted version of the folded impulse response. So at each time instant we are going to find out how many samples overlap with each other. So for time instant n is equal to 0, you can see that original signal is x of k. It remains here throughout our calculation, but we are actually shifting this impulse response. So impulse response is here when there is no shift, which means n is equal to 0. And here it is also written that n is equal to 0, there is no shift. So take a look that these two samples are overlapped with each other, and these two samples are overlapped with each other, and this third sample is also overlapping with one sample of x of k. So in this way, these three samples are exactly overlapping with the three sample values of original signal. So by using this overlapping samples, we are going to compute the value of our output signal. How? Just multiply these overlapping samples and add up the result to get the required value of output at that time instant. How? 3 multiplied by 2 is 6. Then add 3 plus 0, 3 multiplied by 0 is 0. Then add 1 multiplied by 1 is 1. So it means you have to actually add 6 plus 0 plus 1. So it means 6 plus 0 plus 1 will give you the output 7. So 7 is written here, you can see in this slide also. So you will get the output at n is equal to 0, which is when the folded version of impulse response is not shifted. Now you have to find the response or sample value at time instant n is equal to 1. So you will consider this sample values, that is 231, and the original signal values which are at the top row. So here you will see that 2 is overlapping with 0, 3 is overlapping with 1, and 1 is overlapping with 0. So again the same strategy, you have to multiply the overlapping samples and add up all the values. So 2 multiplied by 0 is 0, plus 3 multiplied by 1 is 3, and 1 multiplied by 0 is again 0. So you will get 0 plus 3 plus 0 is equal to 3, which is written here. So the value of output sample at time instant n is equal to 1 is 3. So similar procedure is applied for the time instant n is equal to 2. Here you can see the shifted impulse response 231, and it is overlapping with 105. So you have to multiply the corresponding sample values. 2 multiplied by 1 will give you 2, 3 multiplied by 0 is 0, and 5 multiplied by 1 is 5. So 2 plus 5 is 7. So the output sample value at n is equal to 2 is 7. Similarly, for n is equal to 3, you will have this shifted signal. Overlapping samples are 2 and 0 and 5 and 3. One is not overlapping with any sample. So you can assume a value of original signal or input signal as 0 here. So 1 multiplied by 0 will give you 0, or just you have to discard this number as it is not overlapping with any other sample. So we have to consider only the overlapping sample values and multiply them. So 2 multiplied by 0 is 0, and 5 multiplied by 3 will give you 15. So here we will get 15 in this way. Similarly, 5 multiplied by 2 is 10, you will get 10. 3 is not multiplied by any sample because we do not have any sample value for x of k at this value, or k is equal to 5. So 3 is not multiplied by with any number, and 1 will not be multiplied by any number. Just you have to discard 3 and 1. Just consider the overlapping sample values and multiply them. So 5 multiplied by 2 will give you 10. The same sequence will be followed for all these values such as -1, -2, -3 and so on. Here you can see that your signal is shifted to 1 unit, and by shifting 1 unit you have complete overlapping with the original input signal. 2 will be multiplied by 2, 3 will be multiplied by 3, and 1 will be multiplied by 0, and all the products are then added together. So we will get 13 as an output sample at n is equal to -1. Similarly for -2, we have 2 overlapping here. 2 is discarded because it has no overlapping with any sample value of x of k. So we just have to multiply 3 multiplied by 2, and this 3 will be multiplied by 1. So we will get 9 for this step. Coming towards the last step or last shift, in which only 2 is overlapped with 1, and 2 multiplied by 1 we will get 2 as a result, and these two samples 2 and 3 will be discarded because of the same reason, that no value is here for input signal. So basically, by doing this procedure, by following this procedure, we actually obtaining the output results and the values of output at each and every time instant. And if we want to just write the result what we obtained by following this procedure, if we can write in this form, you can see that result is indicated as y of n, and y of n has these number or these sample values. And from where we get these sample values, these sample values are exactly the same as written here vertically, but you have to take care of the arrangement of these value, and the center value or the pointer value, which will be the pointer value will always be at n is equal to 0. So just mark at a simple arrow below this value, or you can bold this value or underline this value to indicate that this is a center value, or this is the value at or this is the sample value at sample n is equal to 0. So by indicating this the center value, we can move forward to obtain the sample number +1, +2, +3 and +4. And similarly for left hand side, -1, -2 and -3. And how we arrange these values, at n is equal to 0 we have put here 7, and how we get 7 here, we just look at this table. At n, this is the vertical column for n, at n is equal to 0 we have a value of 7, so we have write 7 here. For positive 1 we have value of 3, so 3 is here, and for 2 we have a value of 7. So in this way, whatever values we get at the sample values, so these corresponding sample values are basically the output values. So we just arrange it in the sample number order. Here it is 0, 1, 2, 3, 4, 5, and -1, -2, -2, -3, -4 and -5 and so on. So whatever value we get for these n value, we will just write here. So you can see for n is equal to -1 we have obtained the value of 13, and 13 is written here at n is equal to -1. So students, this is the procedure which is to be followed to compute the convolution. This is actually a tabular format. Any other format or any other procedure can be followed and also exist in literature, but this is quite simple, and I think it is easier to you can look for the other procedures also. One procedure is graphical format, but there is a chances of error in that method if you don't compute or just graphically draw any pattern or sequence value incorrectly. So you may have some error in your answer. So this is quite simple and straightforward method in which the chances of error are quite low. So I prefer you this method to solve discrete time convolution. However, it is very simple, but you can recheck your answer with some alternate method, and I will also tell you an alternate method to verify your answer also. So you can just follow this method and you can verify your answer with any other method which may be easier as compared to this or shorter as compared to this. So we will discuss that method in the later slides. So students, we will get the our desired result of y of n. One interesting thing I would like to add here is that you can also determine the length of this output signal before calculating the actual values. You can at least predict the number of samples you will get for y of n just by looking at the impulse signal and the input signal. And how you will do it, we also have discussed it in the previous lecture, that if m is the number of samples for our input signal, that is x of k, and n is the number of samples for impulse response, then the total number of samples for our output signal will be m plus n minus 1. So I have added this in the slide also for your convenience. Length of y of n is equal to length of x first signal plus length of h second signal minus 1. So here you can verify this also. Your original signal x has a length of 1 2 3 4 5 6 samples, and your impulse response has 3 samples. So 6 plus 3 is 9 and 9 minus 1 is 8. So you will get 8 sample in your output signal. So let's count the number of samples we are getting in the output signal. We exactly obtaining 8 number of values in the output signal, that is y of n. So just by looking at the input signal and impulse response, you can at least predict the number of samples which you will obtain after performing convolution. So you can also verify your answer from this also, that if you are getting exact that number of samples, so but you will not assure that the values are correct or not. Another method will be followed for this, but at least you have a guarantee that number of samples are accurate. Another interesting thing is the indexing of y of n, and by the term indexing I mean to say the values or the range of n, which is n is equal to 0. Just I'm showing with the pointer here, it is n is equal to 0, n is equal to 1 2 3 4. So n is varying from 0 to 1 2 3 4 from to the right hand side, and minus 3 to the left hand side. So this thing you can also predict before actually solving the convolution, and the formula for predicting these or getting this number or range of n is by using the formula written in this slide. Minimum n for y of n, so minimum n of x or plus minimum n of h. So it means again you have to use your original signals, which are the input signals and the impulse signal. So here you can see that the range of input signal minimum value is -2, and the minimum value of h or impulse function is -1. So -2 minus 1 is -3. So you will get -3 will be the minimum value or minimum indexing value for the output signal, and you can verify this from the obtained result also: 0, -1, -2 and -3. So the minimum indexing value or sample value is -3, and maximum value, similarly, maximum value of n, which is 3, and maximum value of h is 1. Add up all these two indexes, 3 plus 1 is 4, and exactly you are obtaining the index value of 4, 0, 1, 2, 3 and 4, and the value at sample 4 is 10. So by this method you can predict actually the length of your output, the minimum indexing value of your output, and the maximum index of your output. So by this mean you can at least verify your solution that your solution is correct or not in terms of its range and length. So I hope that this method is quite clear to you. Now moving on towards the alternate method, just I have discussed before. So you can use that method to verify your solution. So moving on to the alternate method. So students, this is the alternate method to calculate the output from input and impulse response, or generally we can say from this method we can compute convolution of any two signals to yield another signal. So this method is quite simple. As you know that you have been provided with two signals to perform the convolution. First signal will be your x of n, and the second signal will be your h of n, and sample values for these signals will be given to you to perform the convolution operation. You can observe from the given table that we have used the same signal. Actually this one is x of n and this one is h of n. So actually sample values are written here. Horizontal one is x of n and vertical one is h of n. You can swap these values also, but in general case we have large number of values for input signal, so we prefer to write it horizontally and h of n is vertically, but again it's your choice, you can swap these signals also. So and also please note that we have marked the center value or the pivot element or the pivot sample for x of n also and y of n by highlighting it as underlined. So by this mean you have first to write the original signals, and now we have to perform the convolution. So actually convolution is performed to this signal by this method very simply. How? Actually we have to fill all this table, and how we can fill this table? Just multiply the horizontal and vertical sample values. What I'm trying to say that, for example, if you want to calculate the value for this cell, just multiply horizontally and vertically sample values, which means 2 is multiplied by 1 to get the value for this cell. Similarly, if you want to compute the value of this cell, the value for x is 3, the value for y is 1. So just multiply it, we will get 3. Similarly, 1 is constant for the entire row, but the signal x of n values or sample is changing at each cell. So for this cell 1 is multiplied by 0, so output is 0. For this cell 1 is multiplied by 1, so we will get output 1. For this cell again 1 is multiplied by 0, result is 0. For this cell 1 is multiplied by 5, so we will get 5 as a result. Similarly, for the second row, this value, previously we have multiplied all these numbers with 1. Now we are going to multiply all these sample values with 3. So 3 2s are 6 for this cell. 3 will be multiplied by 3 to get 9 for this cell, and similarly we will obtain all the values for this row also. So by this means we have to fill all the values. Similarly for this row we calculate all the values in similar fashion. If we have another value for h of n, we will multiply and add an additional row here, and we will fill all these cells accordingly, just as we discussed. So the solution does not ends here, but actually now we are going these cell values to calculate the convolution result or y of n. So process is quite simple. Imagine you are drawing a line with a slope, or a line with an angle of 45 degree, just like I am indicating the pointer, and it is cutting the cells. So the first line you will draw with first cell, so only first cell will be encountered in this line. So, and what the value of this cell is? 2. So write 2 as the first value of your output. So here you don't need to arrange the values, you are getting the values in the same pattern as we are supposed to write in the result, which is y of n. So first value is 2 by diagonal placing the line. Second value will be diagonally we place the line, and it will pass through these two blocks. So we will get 6 plus 3 9. So actually whatever the values we are getting here, we have to add up these values. So we will get 6 value for the second diagonal line and 3 value for the same line is cutting the 3. So we add 6 plus 3. So we will get 9, and 9 is the output for our convolution. Here you can see 9 is the output. Third diagonal line will cut 4, 9 and 0. So result will be 13. 13 is written here. Next diagonal line will be 6, 0 and 1, which is 7. So you have write 7 here. So in the similar fashion you can find the remaining values, and for your convenience I have highlighted the blocks or cell with the same color, which actually passing through the same diagonal line. 2 is all alone, so color is different. 6 is passed by the same line which 3 is passing, so I have colored these two cells with the same color. 490 again with the same color, 601, 030, 205, 015 and 10. And you can see from the output I also use the same color notation here, so you can understand better by this color combination. And when you are doing it practically, you will be smart enough to draw the lines, or just use it just solve it at your in your mind. So just write the result. I have used these color schemes for your understanding only. One additional thing I would like to add here, that how you will find that which one is the center value. It's very simple. Actually again look at the sample values of original signal. H of n has the center value 3 and x of n has the center value of 0, and actually this cell is cutting these two values, so we have highlighted this 0. And when we draw the diagonal lines, whatever the result will be, we will assume it as the center value or the pivot sample. So 6, 0 and 1, these three values will be add up and the result is the pivot element, which is 7. You can also verify it with the result. After completing the convolution topic, now we are moving towards the similar topic, which is very similar to convolution. So, but the application is different, obviously. Hence, it is named as discrete time correlation. And by name, you can think that this actually technique is used to find the correlation between two signals. Signal can be of any kind, any pattern, any category, any classification. So if you want to find the degree of similarity between that signals, you can use the correlation. So basically correlation is broader term, and it can be classified into two subcategories. First one is autocorrelation and the second one is cross correlation. So here autocorrelation is discussed, and you can see that it is used to evaluate the similarity between the same signals. So then if you can ask me what is the need to calculate the similarity between two same signal. If these signals are similar in nature, then why we are calculating the degree of similarity? So answer is this, that actually this kind of scenario is actually we are using in practical application. You can think of I've discussed one application of DSP, which is object detection. So think of it, actually we are assume that we have to detect an object, and we actually are transmitting a signal, and that signal will hit the object or the target, and it will be reflected back to us after hitting the target. So the transmitted wave, whatever the pattern of transmitted wave will be, the same pattern will be of reflected wave, but there can be a time lag or time shift between these two sample values or between these two signals. Pattern is the same, but phase shift or time lag can be the different. So in this way, this autocorrelation is very useful in calculating the distance of object, because the signals, transmitted signal and reflected signals are same, but we have to find the correlation, how the transmitted signal is correlated to the reflected signal, to judge the distance between the object or the target, or to calculate the distance between the object and target. That is what actually radar does or sonar does. So mathematically you can see that this is the mathematical expression of autocorrelation, and you can see that both the signals are same, x of n, again product will be, both the signals are same, x of n is multiplied with its shifted and folded version, so both the signal is x. So and then after taking the product, we are adding up the results. So you can see from the mathematical expression, this expression is similar to that we have used in the convolution. So mathematical expression is same, So same procedure will be followed to calculate the discrete time correlation, just we have discussed in convolution, but the application is different. Here we are using two similar signals. In convolution we are actually using one signal as an input signal and other signal as an impulse response, but here we are using two similar signals to find the correlation or degree of similarity between these two signals. So here you can see both the signals are x of n and L is indicating the time lag. Another classification of correlation is cross correlation, and as its names imply that it is used to calculate the degree of similarity between two different signals. If you want to compute that how one signal is similar to other, or how much amount I have to shift one signal to make it like the another signal, you can use this type of correlation, which is actually cross correlation. Again, you can see here that formulas are same but different signals are used. First one is x of n and second one is y of n. So you can actually, and another formula is x of n plus L or y of n. So this actually indicating you can either shift and fold any of the signal, either x or either y. So by this mean you can calculate the cross correlation. I am assuming and hope that you have learned the convolution concept very deeply. So this discrete time correlation is very easy to you because the concept is similar to discrete time convolution, but application wise it is different. Mathematically same procedure will be followed, but for your convenience I have added a numerical or practical example how you can compute the correlation in the next slide. So here you can see that you have to calculate the autocorrelation for the signal x of n given as 1, 2, minus 1, just an arbitrary signal. And you will not ask me that why only one signal is given, because we have to calculate the autocorrelation, and autocorrelation we have to find the similarity of signal with its own self, so we don't need the second signal. So the same procedure is followed. First signal will be x of n, second signal again will be x of n. You can see here first one is x of n, second one same, because same samples. You can see we are just time shifting this simple, time advance and time delay, and calculating the values with the same procedure just we have calculate in the convolution. So we will get the result, this result. From this result you can say that the maximum value of correlation you are getting here 6. 6 is the maximum value in all these output values. It is 0, it is minus 1, maximum value is 6. So you can say that this signal is, and you can also see that our pointer lie at 6. So you can say that you do not need to shift your signal to get the maximum correlation. Your two signals are in correct position to have the maximum similarity. Consider a situation if your result will be like this and your pointer is at 0. So you will comment that you have to shift your signal by 1 unit to get the maximum correlation. So I hope you are getting my point. How we can use this correlation technique to find the similarity and how we can comment on the result also. In this slide I have used two different signals to determine their correlation, and obviously different signals are used, so we have used the cross correlation. So here first signal is written as 1 2 minus 1 as given. Second signal is this 3 6 minus 3, pointer value at 3, so we have write 3 from here and so on. And after calculating the correlation result, again by using the same convolution technique, we will get these results. So again from these results we can comment that if we shift the signal by 1 unit, we will get the maximum correlation, as 18 is the maximum value in these sample values. Normalized correlation is basically just dividing your sample values obtained in the convolution result with the signal energies. If your signal is similar, it means you are using autocorrelation, then it is just ex square and square root cancelled. So you just have to divide your result with the signal energy, and if the two signals are different, you have to divide by this factor. So in this value you will get, in this pattern you will get the normalized value of correlation. So this is all about this week lecture. This week we have learned discrete time convolution and correlation. I would like you people to search for more practical application in your field, which is biomedical engineering, so you will explore more the importance of discrete time convolution and correlation.